All right, so let's try example number 3. Let's find the horizontal and vertical aspects of the function. So in this case, we're given a function that is expressed as x squared plus 2x plus 1 all over x plus 1. They want us to find the end behavior of this function, in other words, find the horizontal asymptote of this function. What I would recommend is to automatically write this in a factor form. So if you can factor it, that would be amazing. You don't have to right away, but it makes it easier later on. So what I notice here is that what we notice here is that these two are sort of simplifying though, right? If you notice, we have x plus 1 on the numerator and x plus 1 times x plus 1 all over x plus 1. So we could think about that one of the factors can cancel each other out and give you x plus 1. Now, these two are not technically the same. They're not the same. Not the same. Um, they're not the same, but they behave the same way. So these two functions are not the same. What I'm saying is that this function is not the same function as this, but they behave the same way. They look almost the same. The difference here, the only difference is that this one has a hole and this one does not have a hole, right? So we have to the only difference between those two is that we have to make sure that when we draw this picture that we draw it with the hole. We'll talk about the hole in a second. But because they behave the same way, they will have the same horizontal asymptote, they will have the same vertical asymptote. Everything is going to be the same, x-intercepts, same y-intercepts. Everything is going to be the same except that there's a difference between them, the whole, right? And we'll talk about that in a second. So because they have the same behavior, they're going to have the same end behavior. So when we look at the horizontal asymptote as x goes to infinity, we could say that the limit of fx is going to be the same limit as x plus 1. So they're going to have the same behavior, so therefore we can just use this instead of this because they have the same behavior. And I'll show you guys the picture in at the end of this video. So if we apply this, then that means if we replace x with infinity, then you have infinity plus 1, which will give us infinity. Right? Same argument will happen with as x approaches negative infinity. So now you have replace x with negative infinity. Well, negative infinity plus 1 is still negative infinity. Right? So now we can see that this is not approaching a specific value. This is just keeps going higher and higher on the right side of the function. And on the left side of the function, it keeps going down and down and down. So is there a horizontal asymptote? And the answer is no. No horizontal asymptote for this function. Because those are not real values. Let's move on to part B. Let's find the vertical asymptote. So like we said before, these two have the same behavior. So what we're going to do here is we're going to say, well, the behavior of the function x plus 1 times x plus 1, they both share the same vertical asymptote. And we know that this other function, right, x plus 1, well, because they behave the same way, and so if this one has a vertical asymptote, then this will have a vertical asymptote. The same argument, if this one has a vertical asymptote, then this will have a vertical asymptote because they have the same behavior. Well, what we know here is that this does not have a vertical asymptote, right? This is just a polynomial. So this does not have anything that will make this undefined. So therefore, this has no vertical asymptote. So this implies that this has no vertical asymptote. There you go. and then finally the whole, right? So there is a hole in this problem, and the hole is going to be we can find it anytime we actually cancel a factor, as we mentioned in the previous video. Whenever you get to cancel a factor, right, in the numerator and denominator, this becomes a whole. This is a sign of that you have a whole, that the function has a whole. And where is that whole going to be? That whole is going to be at x plus 1 equals 0, right? So I'm going to write it here. So these two, because the fact that these two are going to cancel each other out, x plus 1 will be set equal to 0 and be solved for 0, for x. This will give us x equals negative 1. So at negative 1, we'll have a whole, but we're going to actually find the whole because the whole is actually in a order pair. So what we need to do is plug this into the original function, or in the function, which is x plus 1, and plug in negative 1 in there. And what do we get? We get 0. So the y value for this is 0. So the whole is at negative 1, 0, right? X is your y, it's negative 1, and y is 0. All right. So there you go. So let's go ahead and jump in and find Desmos here real quick. Where's Desmos? All right. All right. So we're gonna graph both functions so you guys can kind of see what I mean by this. F of it's not gonna let me. Y equals x. Let me make a division here. Okay. All right. So here we have a so that's how this looks like, right? This is how the original function looks like. And if I type in the simplified form of this function, then you see the green line right there, right? So the green line does not have a hole, but the other function does, right? So if I remove it versus if I play, so they both have the same behavior. If you notice, the end behavior is the same, right? And so the only difference is that the original function has a hole at negative 1, 0.